Thanks to CuriosityStream for supporting PBS Digital Studios. If you've ever looked at the night sky, you've probably wondered, what's out there? How far does it extend? Well, you're in good company. For thousands of years, humans have been curious about what's off the edge of the map. Today, science may finally be close to giving us answers to even bigger questions. Does the map even have an edge? And what's the farthest away anything can be? When humans first started mapping their location in the world around the 6th century BC, the edge of the map was not very far away. Our earliest world maps showed flat, circular views of the Earth, like you draw from a mountaintop, if the Earth was flat, which it's not. In fact, the Greek scholar Eratosthenes figured out that the Earth was basically spherical around 240 BC. He used the midday sun to calculate the circumference of the Earth, and he got results within 15% of the actual value. But still, for centuries, maps were flat, centered around whoever drew it, whether they were in Europe, the Arab world, or even China. And at the edges, map makers would often inscribe, "Here be lions," to indicate unknown lands. Not "Here be dragons," like I've always believed. Now, explorers continued to exchange knowledge and discover places that people already lived, and our picture of the world expanded. Our world map was finally complete with the discovery of Antarctica in the 1820s, and suddenly, the edge of the map became the sky itself. In the 1830s, we discovered that stars are vastly farther away than planets. Duh. We figured this out by measuring how different astronomical objects shift relative to their background, a phenomenon called parallax. The edge of our map now extended beyond our solar system to the galaxy. Of course, by the 1900s, we still thought our Milky Way galaxy was the whole universe. Here's the challenge that astronomers faced. If one star is dimmer than another, is it farther away, or is it just smaller? In the early 1900s, astronomer Henrietta Swan Leavitt realized a class of stars called Cepheids pulsate, bright and dim, and every Cepheid that pulsates at the same rate has the same brightness. Now, if two Cepheid stars are pulsating at the same rate and one is dimmer than the other, that means one is actually farther away. And since there were pulsating Cepheid stars whose actual distances we already knew, that let us build a cosmic measuring stick. In 1925, when Edwin Hubble looked at the brightness of variable stars in a smudge called Andromeda, they appeared much dimmer than their pulsing rate predicted, and Hubble realized these stars were too far away to be in the Milky Way. Andromeda was another galaxy, which on a dark night is actually the most distant thing that you can see with your naked eye. Using bigger eyes, like the giant space telescope named for Hubble, we've seen images in which every speck is its own galaxy, the farthest of which is more than 13 billion light years away, almost the oldest light we can see. When we look at a galaxy like this one, we see it as it was when the universe was just 400 million years old, before Earth or our sun even existed yet. We also don't see distant galaxies where they currently are. Certain stars, like our sun, emit light in characteristic patterns depending on their atomic makeup. Now, these absorption spectra are like a luminous fingerprint, but if we see that pattern at longer, redder wavelengths than we expect, we know the object is actually moving away from us. Its light has been stretched by the expanding universe. Astronomers call this redshift. So, in the time light takes to reach us from a distant galaxy, it's moved farther away. So when we look at a distant galaxy, we're seeing it as it was when it was much younger and much closer. Imagine your friend sent you an email from a train saying she was just crossing the bridge leaving town. By the time the email reaches you, she's no longer on the bridge. Here's where the physics gets really weird. Since it was given off, the light from a distant galaxy like GNZ11 traveled more than 13 billion light years to get to us. But that galaxy today is almost 46 billion light years from Earth. And it turns out, the further we look at distant objects, the faster they're moving away from us. This means there's some distance way out there, beyond which galaxies are receding faster than the speed of light, because space itself is expanding that fast. The light they give off will always be moving away from us. We can never see that far. That's the limit of our observable universe. Beyond that limit, we're nearly certain there are other parts of the universe whose light we'll never see. This means no one really knows how big the actual universe is. Some say it's at least 250 times bigger than our observable universe. Others calculate it could exceed 10 to the 10 to the 10 to the 1,222 megaparsecs, which is a vast and complicated and ridiculous number. Others say there's no edge at all.
No edge!
There's one edgeless theory that says that the fabric of the universe may be folded up like a torus, a fancy donut shape. That would mean not only no edge to our cosmic map, but no beginning or end to it. What's farthest away may not be a question that we can answer. However, we're driven by the same curiosity that drove those very first map makers thousands of years ago, just that their maps were a bit smaller. Stay curious and be careful. There be lions out there. I want to say a big thank you to CuriosityStream for supporting PBS Digital Studios and our show. CuriosityStream is a subscription streaming service that offers documentaries and nonfiction titles from a variety of filmmakers, and their collection features a bunch of CuriosityStream originals. Now, if you enjoyed this trip to the edge of the universe, then you should check out this original series from CuriosityStream, where the late great astrophysicist Stephen Hawking takes you on a tour of his favorite places in the universe and explains how they got the way they are. You can learn more at curiositystream.com/smart and use the code SMART during the sign-up process.